Radical functions and solving radical equations. First thing we're going to take a look at is the graph of y equals square root of x. Since this is the most basic function of this type, it is the parent function. And every other square root function is some kind of transformation of this parent function. Let's take a look at the graph. I'm just going to pick real simple points, ones that I can do easily. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Notice that we can't plug in -1 because we get imaginary numbers. We're not going to do any negatives. So normally, y will always be positive. Graphing this, 0, 0, 1, 1, 4, 2, and 9, 3, we get this curve here. It looks like half a parabola turned sideways. The range of this function, that's the y's, remember, is all y values, a set of all y, such that y has got to be greater than or equal to 0. We know y is always positive. In interval notation, we can include the 0, but we'll go from 0 to positive infinity. This is the range in interval notation. The domain is the set of all x's, and every x is greater than 0. In interval notation, we can include the 0, and again we go to positive infinity. Now keep in mind, as you answer these questions, that every other square root function is some kind of transformation of this parent function. And think about how that would affect the domain and range when you answer your questions. When you solve an equation with a square root in it, or any kind of root, you need to get the root by itself, solve for that root. In this case, we would subtract 3 from both sides to get the root by itself. And then we do the inverse to eliminate that root. The inverse of a square root is a square, and I just square both sides. If this had been a cube root, I would have cubed both sides. If it had been a fourth root, I would have taken both sides to the fourth power. Do the inverse to get rid of it. Now the square and the square root are inverses. They cancel out. I get x equals 9. These become a lot more involved, but remember the goal is to get the root by itself. In a case like the problem in blue, the root is by itself. I would square both sides, but be aware that this has to be FOILed. You cannot distribute an exponent. You're going to have to take x minus 2 times x minus 2 and work it out. X times x times -2 times x, -2 times -2. This becomes 5x minus 10 equals x squared minus 4x plus 4. This is a quadratic. What you need to do is get it equal to 0. 0 equals, we'll subtract 5x, x squared minus 9x, and add 10 to both sides, plus 14. Then what we need to do is find factors of 14, since there's no number in front, that add to -9. And that would be x minus 2 times x minus 7. We can see right here that plugging in 2 makes 0, and plugging in 7 makes 0. And 0 times anything will make 0. Now the thing to watch out for, my answer is x equals 2 and 7, not an ordered pair, they're both x's. Sometimes when you plug these things in, they don't work because, for example, the square root may end up being negative. Notice that if I plug in 2, 5 times 2 is 10, and 10 minus 10 is 0 on this side, 0 squared. Over here, when I plug in 2 minus 2 is 0. 0 squared equals 0 squared. It does work. And 7 works also. But occasionally, you'll get a case where one of these doesn't work. It's called an extraneous answer. We toss it because I can't take the square root of a negative. It's even possible that maybe both answers wouldn't work and you have a no solution. In this example, we need to eliminate a fifth root. We do that with a fifth power. The fifth root and fifth power are inverses of each other. That leaves us with 9x minus 6. And over here, we get x. Subtract an x from both sides and add a 6. 8x minus 6 equals 0. Add 6. 8x equals 6. And divide by 8. X is 6 over 8, but that certainly simplifies. Divide both by 2, and we get 3/4. Question 1. Graph the following radical function and state the domain and range of each as an inequality. These transformations are all vertical transformations. Y is going to be the opposite, and it's going to decrease by 2. So the opposite of 0 is 0. Decreased by 2 is negative 2. Guess I should put these x values in. The opposite of 1 is negative 1, and down 2 would be negative 3. The opposite of 2 would be negative 2, and down 2 would be negative 4. And the opposite of 3 would be negative 3, and down 2 would be negative 5. Graph would look something like that. And we're going to state the domain and range as an inequality this time. The domain are the set of x's, and they are all greater than or equal to 0. And the range are the set of y's. Look at the graph. The y values are all less than or equal to negative 2. Here we have another transformation. This is horizontal because x is being replaced with x plus 3. And remember that horizontal is the inverse. Rather than moving it 3 right like you'd expect, it moves it 3 left. Now, keep in mind what the graph looks like, the parent function. Let's do that lightly in blue. 0 is 0, 1 is 1, the square root of 4 is 2. So it's this graph right here. And this is going to be the exact same graph, it's just going to move it 3 to the left. So 0 goes to negative 3, 1 goes to negative 2, and 4 goes to 1. For the domain, the x's are all greater than or equal to negative 3. Notice that plugging in negative 3 for x makes the square root of 0. That's the smallest that x can be. The range, all the y values are greater than or equal to 0. Question 6. All the transformations here are just shifts, so there's no compressions or stretches. Based on that, what would this equation be? It would be y equals, we've moved it 2 to the right. Remember that's horizontal, it's the inverse. So x got replaced with, this is the square root function, with x minus 2. Then we've moved it 1 up, because normally the square root of 0 is 0. 1 up means we have a plus 1 after the square root, and we're done. This question is shifted to left, then it's reflected over that line. So all the x's become the opposite. This would look like then y equal the square root of, first of all, we're moving it to the left. Now that's horizontal, it's the inverse, so it's x plus 2. And then right after that, it's flipped. So those values all get the opposite. So basically it would have been like this. But all those values become the opposite, and they're over on the other side. But also, everything is moved up 1. So I need a plus 1 after that. Question 10 is a quick one. We're shifting it 5 to the right, and that's horizontal. It's the inverse. So x is being replaced with x minus 5. Remember, to the right would be plus 5, but it's horizontal, so it's the inverse, minus 5. And then we're moving everything down 1, so every y value gets decreased by 1. And there it is. You can graph this and figure out by that what the domain and the range are. The thing you have to remember is that the smallest number you can have under a square root is 0. Square root of 0 is 0. You can't have a negative. What we know then is what's under the root for the domain has to be greater than 0. 8x plus 11 has got to be greater than 0 or equal to. And solve for x, it's an inequality. 8x is greater than or equal to negative 11. Subtract 11 from both sides and divide by 8. X has got to be greater than or equal to negative 11/8. So for the domain, I can include negative 11/8 because plugging that in makes 0. There is no horizontal reflection. This will be just like the parent function then. It will go forever to the right, so forever in the positive direction to infinity. The range gets affected by this negative because every y value becomes the opposite of what it is. Keep in mind that means that a point up in quadrant 1, an x and a y, will drop down over here and be x negative y will be the opposite. So this graph does this, and it's no longer that. But we do have that minus 1, which moves it down 1 too. All my y's then will be less than or equal to negative 1. So they'll start at negative 1, and they'll go to negative infinity because they'll go down. On a question like this with a square root, you want to get the root by itself. So solve for it like it's its own thing. That means I need to add 4 to both sides. I get 3 times the square root of x plus 3 equals 18. And divide by 3. It cancels. I get x plus 3 equals 6. Now I can do the inverse to get rid of that square root. And I'll square both sides, and those cancel each other out because they are inverses. That's x plus 3 equals 36. Take a 3 off each side, and x will be 33. Always plug it in and check to make sure that you don't get a negative value. Notice that 33 plus 3 is 36. Square root of 36 is 6. 3 times 6 is 18. 18 minus 4 is 14. Occasionally you get one where the answer will not work in the equation. In this question, the root is by itself, so I'm going to square both sides. Be aware when you square x plus 8, that is not equal to x squared plus 16. This is x plus 8 times x plus 8, and you have to FOIL. It has a middle term of 8x plus 8x, 16x. It's x squared plus 16x plus 64. When I square both sides then, I get 3x plus 24 equals x squared plus 16x plus 64. I'll get this equal to 0. I'll subtract 3x, and I get 13x. I'll subtract 24, and I get 40. Factors of 40 that add to 13 are 8 and 5. the solution is what you plug in that makes 0, because 0 times anything is 0. That'd be -8 and -5. But do check to see that they work. Notice that if I plug in -8 in the original question, 3 times -8 plus 24 is 0. That's the square root of 0. And -8 plus 8 is 0, and that works. Plugging in -5 also works. But do check, because occasionally one or both may not work. Question 22, I'll square both sides. This is -3x minus 11 equals, remember this is x plus 3 times x plus 3. We get middle term of 3x and 3x, so it's x squared plus 6x plus 9. Get that equal to 0. It's x squared plus 9x plus 20. This is x plus 4 times x plus 5. X equals -4 and x equals -5. Remember what I warned you about. Plugging in -4, -4 plus 3 is -1. This square root will never be equal to -1. And the same thing happens with -5. -5 plus 3 is -2, and we can't have a square root equal to -2. The square root is always going to be positive. The smallest it can be is 0. It will never be equal to a negative number. Only way we could make that happen is if we threw a negative out in front, and we don't have that here. Neither answer works then, and our answer is no solution, or D, N, E. The solution does not exist. Question 23, let's square both sides and eliminate that root. We have 3x plus 27 equals x squared plus 6x plus 9. We'll get that equal to 0. X squared plus 3x minus 18. Subtract 27 from both sides. Subtract 3x from both sides. Factors of 18 that subtract a 3 are 6 and 3. It's x plus 6 times x minus 3. X equals -6 and x equals 3. Check to see if they work in the question. Plugging in -6, -6 plus 3 is -3. That's not going to work. A square root can't be equal to a negative. When I plug in 3, 3 plus 3 will be 6. 3 times 3 is 9 plus 27, which is the square root of 36, which is also 6, so it works. X equals 3 is your answer. Question 26, get that root by itself. Let's divide both sides by 4. The cube root of x plus 2 is equal to -1. To get rid of that cube root, we'll cube both sides. We have x plus 2 equals -1 cubed. -1 times -1 times -1 is -1. Subtract 2 from both sides, and we get -3. Notice that when I plug in -3, 4 times the cube root of -3 plus 2, does that equal -4? Well, this is 4 times the cube root of -1. I can take the cube root of -1. What number times itself 3 times makes -1? That's -1. 4 times -1 does then equal -4. We can see it works. Question 30, to eliminate that fifth root, we'll take a fifth power. And we're left with 12x minus 10 is equal to x. Let's move the 10 over there and the x over here. We'll subtract an x, and it's 11x minus 10 equals 0. We'll add 10 to both sides. 11x equals 10, and divide by 11. X is 10 over 11, 10 elevenths. Checking this one would not be easy, but we could check it with Desmos. Here's how I would do that. We can't use x and store a value in x because x is for graphing, but I just used a. So I said a was 10/11, so that was our answer. And I plugged in the left side right there and plugged in the right side. And I did the fifth root of 12x, 12a minus 10, and the fifth root of x. And notice how they produce the same decimal. We are absolutely positive then that we have the correct answer.